In a shocking revelation, declassified U.S. files unveil a gripping secret: an otherworldly object struck our planet, setting the stage for a cosmic mystery like no other. But what exactly was this enigmatic visitor, and what secrets does it hold? Stay tuned as we delve into the astonishing tale of Oumuamua. Classified documents have recently been declassified, revealing an intriguing event that occurred in 2014, nearly 3 years prior to the emergence of Oumuamua in the headlines. On January 8th of that year, an unusual object entered Earth's atmosphere, creating fiery streaks across the skies over Papua New Guinea, and eventually crash-landed dramatically on Manus Island's coast. While data collected by certain spy satellites hinted at the possibility that this object originated from interstellar origins, this information remained concealed, enveloping the meteor's source in secrecy for an extended period. Nonetheless, ongoing and recent research has ultimately confirmed that this enigmatic meteor indeed came from a distant star system, earning it the name Interstellar Meteor 1, or Oumuamua. In terms of the timeline, this discovery establishes Oumuamua as the initial recognized interstellar visitor, antedating 2 subsequent objects. The process of confirming Oumuamua's extraterrestrial origin and the reasons behind the nearly decade-long delay in verifying the origins of this celestial body require a retrospective look at the events of 2014. When Oumuamua made impact on Earth's surface on January 8th of that year, it was officially recorded as CNEOS 2014-0108 within NASA's Center for Near-Earth Object Studies. CNEOS data collection. As this meteor traversed Earth's atmosphere, the sensors aboard covered spy satellites under the jurisdiction of the U.S. Department of Defense registered an extraordinarily high velocity for the object, strongly suggesting that it did not originate within our solar system. Fast forward 5 years to 2019. Harvard scientists Avi Loeb and Amir Siraj classified this celestial entity as a possible interstellar meteor. However, their data source exclusively relied on information gathered from spy satellites. Furthermore, due to adherence to defense protocols, the U.S. government did not disclose the precise accuracy of these measurements. These constraints led to the inability of the 2 researchers to publish their findings, leaving the question of whether Oumuamua was genuinely an interstellar visitor or a coincidental event unresolved. However, in 2022, the U.S. government undertook a more comprehensive investigation, ultimately affirming the accuracy of the data. U.S. officials released an official document endorsing the work of Avi Loeb and Amir Siraj, definitively asserting that Oumuamua had an interstellar origin with an astonishing confidence level of 99.999%. Now, the question arises: how did the Harvard scientists initially confirm Oumuamua's interstellar nature? The answer to this inquiry hinges on the object's velocity and trajectory. Using data gathered by spy satellites, researchers determined that when the meteor entered Earth's atmosphere, it was hurtling at an astounding speed of 45 kilometers per second, equivalent to 28 miles per second. This velocity accounted for both the object's movement relative to Earth and Earth's orbit around the Sun. However, upon subtracting other contributing factors and comparing the velocity to the average motion of celestial bodies within our solar system, a glaring deviation of 58 kilometers per second from the mean velocity became apparent. This departure in speed is a characteristic typically associated with objects originating from star systems situated within the thick disk of the Milky Way. Furthermore, the data related to the detected meteor indicated that it originated from an unbound hyperbolic orbit, signifying that it had broken free from its original system and embarked on a journey away from its parent celestial body. Collectively, these distinct attributes strongly pointed towards the meteor being a genuine interstellar visitor, bolstering the confidence level to an astonishing 99.999%. Once the meteor's interstellar origin was conclusively established, the subsequent challenge entailed deciphering its chemical composition. This undertaking necessitated the retrieval of meteorite samples from the impact site. However, a significant obstacle emerged. Oumuamua had detonated near Manus Island, dispersing its fragments across the Pacific Ocean's depths near the Papua New Guinea coastline. As a result, the research team confronted the formidable task of collecting interstellar samples from the depths of the seabed, which extended to depths of up to 2,000 meters. Nevertheless, a dedicated team was assembled for the purpose of recovering material from the deep seabed. Over the course of 2 weeks, they conducted a meticulous survey of approximately 64 acres of seabed surrounding the impact site. This extensive effort allowed researchers to draw comparisons between the typical seabed material from unaffected areas and the material found within the impact zone. It is at this juncture that the narrative takes an intriguing and unexpected twist. The examination of the minute fragments retrieved during this painstaking process yielded astonishing results. These fragments were discovered to be exceptionally enriched in 3 elements: beryllium, lanthanum, and uranium. Remarkably, the levels of lanthanum and uranium in these fragments exceeded terrestrial rock levels by a staggering factor of 500, while the beryllium content surpassed Earth's levels by a factor of 100. This discovery held particular significance because the presence of beryllium is a telltale sign of exposure to high-energy cosmic rays, thus offering additional confirmation of interstellar travel. Moreover, the isotope ratios of iron found within the samples defied our current understanding of the solar system. Collectively, these findings serve to bolster the case for its interstellar origin even further. Based on the chemical composition, it was surmised that the meteor may have once been a component of a larger celestial body, potentially a giant asteroid or even a planet. However, scientists also entertained the possibility that it could have been technological debris originating from extraterrestrial civilizations. Furthermore, another potential interstellar candidate, IM-2, crashed offshore in Portugal in 2017. According to calculations, it now appears that objects of interstellar origin similar to IM-1 might be more prevalent within Earth's orbit than previously believed. In light of these findings, it becomes evident that IM-1 is firmly established as the first documented interstellar visitor, predating the famous cigar-shaped interstellar object discovered in 2017 and another rogue comet named Borisov, which was identified in 2019, all supported by the wealth of evidence indicating its interstellar nature. The story of IM-1, the first documented interstellar visitor, offers a tantalizing glimpse into the mysteries of our universe. From its fiery impact to the remarkable findings hidden within its fragments, IM-1 has challenged our understanding of celestial bodies and raised intriguing questions about the cosmos. As we continue to unravel the secrets of IM-1 and await further discoveries in the realm of interstellar phenomena, one thing is certain: our universe is a vast and wondrous place, full of surprises yet to be uncovered. Do you believe that IM-1 could hold clues to extraterrestrial civilizations, or do you think its composition is more likely a natural occurrence? Feel free to express your thoughts and viewpoints. And be sure to join the Revel Discovery community by hitting that subscribe button to stay up to date with lunar revelations and the forthcoming frontier of space exploration. Remember, as we venture into the universe, the sky is not the limit, it's just the beginning. Keep looking up.